So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their doubts or queries that they may have related to any project that they are doing or any RCC steel design concept or construction and site related queries. So, this is the 51st such episode that we are conducting, and let us start taking the queries that have been asked for this week. So I'll first take the queries from the Google form, and then we will go to the queries from the live audience, if any. So the first query has been asked from engineer Vineet Kumar. He is a working professional from Patna, and he is asking. So he is basically asking about a comparison of a retaining wall arrangement that he has made, and he has made two systems, and he is asking about those two systems. It's a long question. I think you need not read the entire question. If someone wants to read, they may just read it. I am just putting it on the screen, or you read the first part. Here is the description of the system. I hope it's uh, is it readable enough? Let me just check. Yeah, I think you might be able to read this. So basically he is asking about two systems that he has made, and then he has shared an ETABS model also. So what I will do is I'll just try to open that ETABS model, and uh, maybe that will give us some understanding of this system that he's trying to compare. So just hold on while I try to open the system. So this is the screenshot from the system that he has shared, and on your left side you will see so retaining wall is 6 meters, and then on your left side he has provided a heel and toe slab. So the wall is retaining fill from this side, wall is retaining fill from this side. Okay, in this system, this is the, I think this is called as the heel slab, if I'm correct. This is called as the toe slab. So this system has heel and toe, and this is without any heel toe. Okay, and what he has done is he has provided piles over here. So this was the similar question that we were discussing in the earlier Ask AuxEn Anything episode. Just last week we were discussing this. So in these two systems, he has provided piles. So if I were to show you the plan view will look like this. That this is my retaining wall in plan, and in one of these systems he has provided a heel and toe. Sorry. So something like this, and then there are piles in plan that have been provided. I think some one below the wall, one slightly away. So obviously, yeah, something like this, and then tie beams, tie elements have been provided. These are the ties. So if you see closely, uh, this is the tie. This tie goes to this column. Again, there is a tie. This tie goes to this column. And if I were to just zoom into it a bit, what has been done over here, that the piles are provided in between. So I don't know if you are able to see this. This is my pile. This is pile. In between the piles, there is this column. Okay, and then there is this element, and then there is, just a minute. I'll just try to give you a better view, maybe. I'm just trying to rotate it in the model so as to give you a better looking view. Yeah, I think this will give a better view. And there's a two-tier arrangement that has been provided. Oh, okay. So there's a two-tier arrangement that has been provided. Looks complicated slightly. I'll just paste the yeah. So this is that arrangement. Just hold on, I'll be back. Yeah. So not able to see the model. No, because I'm not showing the model. I'm just showing you the screenshots from the model. So there's a two-tier arrangement, and if you can see, uh, where is my pen? Yeah. So one arrangement, one is this tie sort of tie beams. These are the tie elements. These are connected to this column. Okay. Then he has provided another set of tie beams which are staggered over here. So this is connected to this element and they are in between. So it's a sort of complex arrangement that has been done. And his question being asked is, and this he is comparing with another system where he has not provided any toe or heel. So on your left and on your right, between 1 and 2, the only difference is that in 1, toe and heel slabs are provided, in 2, toe and heel slabs are not provided. And then to take this tension load, piles have been provided like this. So these springs that you see are pile points in between this column. He has provided two piles everywhere. So this is his arrangement, and piles have been provided on the other side also, just below the wall. So over here and here, here and here. So this is his arrangement basically. So if in plan view I was to show you, it will look something like this. That this is his column. Okay. Then from the column there's a tie member. Again a column over here. From the column there's a tie member. Again a column from here, tie member. Something like this. This is the upper tie member. There is a lower tie member also, which I am not showing you in the view. So his question is which is better amongst the two? Which system is better amongst the two? That is his question. First question is that. Let me just see if I can share my screen to show you the ETABS model also. Just a minute. I'll just try to see if ETABS model can be shown. Share screen. I think we can. So is this ETABS model now visible? Yeah. So this is his system that he was asking us about. So this is the system with heel and toe. On your right is the system without heel and toe. And then these springs that you see are the pile points being provided. Okay. So his question is which system is better, with the pile or without the, sorry, with the heel toe, or with the heel slab or toe slab, is that better, or one without it? So my views are, let's now discuss this, and I think again go back to the I'll again go back to our OneNote, because there I can write. I'm not able to write it on eTabs screen. So according to me, the toe and heel slab will be better. Toe heel slab is better according to me. This is better. Why this is better? Because there will be soil pressure that you can put on the toe and heel slab also. Now that toe and heel slab soil pressure will provide some counter to the overturning moment. So basically, uh, let's say this is the column that has been provided, then there's a tie like this. Okay. Now if I provide the toe and heel slab, obviously there will be soil fill over here, which will add to the counterbalancing moment to the overturning moment due to lateral earth pressure. So because of that heel and toe, you will get the what do they call it? Balancing or resisting moment. Balancing moment. You will be able to get it from there. So in my opinion, providing a toe and heel slab is a better system than not providing it, because if you are not providing toe and heel slab, you are just relying on the pile tensile uplifts to take all the overturning moments. Okay. So when you provide toe and heel, you have got two sort of systems. One will be your overturning moment provided by by the soil pressure on the toe and heel, and the other will be pile uplift. Whereas if you decide not to provide toe and heel slabs, uh, the entire overturning moment has to be resisted by pile uplift. So therefore, I think one with the toe and heel slab is better. Second thing is, he is asking, from a structural and geotechnical behavior point of view, which system is preferable. So as I told you, the system one is preferred because we are having two load paths, overturning resistance to overturning moment being provided by the soil on the toe and heel as well as the pile uplift. His next question is, in system 2, is it acceptable to rely on tension piles for overturning resistance without a heel slab? I have already answered. Considering the 6-meter wall height, fly ash back, fly ash backfill, and frame plus infill wall system with slant beams, which option would you consider safer and more appropriate, even if it is less economical? So as I told you, option one seems to be better. Then he is asking, also give suggestions about weep holes. Weep holes you can leave as per your requirement. Generally, maybe like this in this framing you have created, maybe uh, generally we leave around 100 dia weep holes. Okay, those you can plan, and maybe the height or the levels can be decided as per your site condition. So providing weep holes is not a problem. And at expansion joint, what material to fill in this situation? So if you're providing expansion joint, and if it is a case of high water table, I will not recommend you to provide expansion joints, because then that may lead to seepages and that may lead to other issues. So if you are providing expansion joint, don't consider filling it. Just have a small gap, because anything you fill, it will deteriorate over time. Generally, they provide non-shrink grouts in expansion joints, but in retaining wall systems, if you have high water table, it won't sort of have a good design life. So you can look at non-shrink compounds over there in the expansion joints. Okay, so these were his query. In the retaining wall, there are, I mean, people, and see, providing toe heel, it will also help you in dissipating the compressive pressures. If you are providing this toe heel slab, what I'll suggest you is to provide area springs to this also, right? Provide area springs below this toe heel slab also, because it will also take some compression. It will also take some compression. Maybe the soil is poor, maybe the bearing capacity at this level is 5 tons per square meter or 8 tons per square meter or whatever. So you may take at least that much advantage as well. So try to take that advantage, and you can consider providing toe and heel, sorry, soil springs to toe and heel slab. Mr. Vineet is saying, who had asked the question, option one comes highly uneconomical. So why are you providing these two tiers? I'm not getting. Why are you providing these two tiers? This I'm not quite convinced why at two levels you have provided these beams. At one level it should be enough. And see, it's a cantilever, so you need not take your tie beam till the very top also. You can just consider providing tie beam at some mid height like this, and then connect it to column. Okay, because in the cantilever what's happening, if you are able to control somewhere at the mid height, it will help you to it will help you provide significant reductions in the movements, right? So instead of providing two-tier tie beam system that you have provided, my suggestion would be you can just consider providing one, maybe at the somewhere at the mid height or slightly above the mid height. Even this should work well. 6 meters is not very tall. Okay, so at 3 meter or at around 4 meter, you provide this tie and have some framing system. You can eliminate this beam can be eliminated, it's not helping you. This beam can be eliminated, it's not helping you. Just have this tie beam and this column, and that's it. Okay, this beam is also, this horizontal member is also not helping you. So just have two elements and try to redesign. Just have this, that's it. Okay, I think most of the elements that I see are not required. There are just too many elements that you have provided, and have toe and heel slab with it. Clear? So try this out. Maybe it might be helpful for you. Mr. Vineet is saying, should I check deflection at top? Yeah. Now see, deflection at top is a tricky thing because you will get some deflection at top over here. Now, what should be the allowable deflection value at the top? That is not very clear. So your code does not give you any guideline on this deflection at the top point. So my suggestion would be, as long as your let's say sliding overturning checks are satisfied, okay, as long as your sliding overturning checks are satisfied, as long as your bearing pressure checks are satisfied, as long as your pile reactions are satisfied, I think you may not check the deflection, because you really don't know with what value to check deflection for. You get my point? So what is the permissible acceptable value for this top deflection? We really don't know. So as long as other checks are satisfied, and see, deflection in this kind of a structure, serviceability issues are not very important for retaining walls, right? So even if there's a slight deflection, maybe serviceability wise it's not a big problem, and that is the reason why, as long as other checks are satisfied, uh, I think you should be good enough. Mr. Vinith is saying, if I give frame system, then the slab in between needs less thickness. Which slab? The toe and heel slab or the wall? Which slab are you talking about? I'm not sure which slab he's talking about. The wall. Okay. Okay. So then, if you are doing it for the wall, the orientation of this is also improper. You should consider rotating it by 90-degree. Right now, you have provided your element like this. So if it's for the wall, this orientation is not helping you. Then you consider reorienting it like this. You understand? If you want to support the wall, you consider reorienting your elements by 90-degree to this. Yeah. So that consideration you can try and have. Okay. All right. So, and I still think you can try it out. You can try it out. Use, but maybe if you give just one system like this, something like a counterfort, okay, and have it stiff enough so that your walls, you get major bending in this direction. Try to have it like this. So for that, you may have to stiffen up your this system over here, vertical frame. You may have to stiffen up, and if you're able to get sort of one way behavior in the slab like this, maybe then you can eliminate this thing and this thing, and maybe that overall costing and overall construction time gets reduced. Okay. All right, so think about it, and then if there are any doubts we can discuss it further. So this was Mr. Vineet with this question, and the next query is from uh, next query is from engineer Karthikeyan. He is an independent consultant from Chennai, and he is asking, please clarify the design query regarding raft. Have mailed you the details. Before that, I think there was some pile arrangement is correct. Pile arrangement is okay, but you can see why. I mean, that you have to decide as per your pile capacity that why these two piles are so close to this column. So for one column, you have provided two piles like this. What I understand. So maybe you can consider. I mean, let's say you have this system. Maybe for piles in between this column and this column, have one pile. Then in between this and this, have one pile. Maybe that will be more economical instead of having multiple small piles. Try to have a one slightly larger dia, maybe till a greater length, because see, providing so many piles close to each other, even though they may be as per the minimum spacing criteria of the code, is a problem on site if you have to do multiple piles so close to each other. So instead of that, think about having a few piles, maybe those are larger in length so that their uplift capacities are higher, but they are fewer in numbers. So you can think about that also. Okay. Then who was asking this? Mr. Karthikeyan is asking, what is the geometry of the retaining wall system? I don't know if there's some name to this geometry. I'm not sure. Then any related query? No. Okay, so then we move on to the next question, and this has been asked by engineer Karthikeyan from Chennai. He is an independent consultant, and he has shared some photos on the email. And two images he has shared. How to rotate this? Rotate anti-clockwise. Rotate. Yeah. So his question is shear needs to be checked. What is this question? Okay, he has put the query in his email. So let me. Please explain the query in the attached images. Reference raft foundation. Query is primarily how the raft to be designed for shear. Please explain case 1 and 2, whether the portion between column to D distance can be ignored in case 1 and distance D minus X can be ignored in case 2. Overlap zone shear to be checked for enhanced shear yeah, correct. D minus X shear not to be checked. What is D? See, I'm not fully understanding the query, but I'll just explain. Let's say if you have two columns which are close to each other, and this thing happens in structures where you have deeper rafts, okay, and let's say in cross section, this is your column, this is your column, and then you had a deep raft, something like this. And now what's happening is that when you are going to check for shear, you see that from d distance, if you were to take d distance, it sort of intersects with the d distance of the other column. Yeah, so in such cases what to do, in such cases what to do so the simple concept that you can use in such cases is that you find out the shear at this location first. Okay, you find out the shear at these locations, and then use, as you have rightly pointed out, the enhanced shear concept. So because this section is within the d distance, so from here the d distance section was like this, let's say, and for this column the d distance, let me use some other pen. So for this column the d distance section was here, and for this column the d distance section was here. So you can say it is sort of intersecting those d distances. Now what to do? So in such cases we will usually, as you have rightly pointed out, use the concept of enhanced shear in this overlapping zone. So because the critical section is within the d distance region, what you do is you just find out the shears in this region from your analysis, and whatever the analysis shear you get, you check it against enhanced shear concept, enhanced shear. So basically in enhanced shear you are allowed to multiply the tau c by 2, what is the value, 2 d upon av, something like this, or 2 av upon d, 2d upon av, correct. So you're allowed to multiply it by this multiplying factor, where your av will be the distance at which you're checking the critical section at, and it is smaller than d, and so this is the multiplying factor. So whatever shear you have, analysis shear, you check it for that enhanced shear value. In case 2 in portion d minus x shear to be, I'm not clear what is d minus x. So from this face, he is saying from this face, this is the d distance, and from this face, this is the d distance, and then what is d minus x? Acha, x is this overlapping, and this is d minus x. Don't get confused. See, this is d minus x is nothing but av. So wherever you are checking over here, if you are checking over here, okay, this is within the d distance. For this column 1, this this is within the d distance, this section is within the d distance, so you check it, this becomes your av, and 2d upon av, you multiply it by tau c and check. Now since for this column, okay, since for this column you have already checked that d distance, so this section is not important for the column number 2. You get my point? So this section, let's say xx, is important for column number 1, and for that you consider this as av, let's say, and you check it as per 2d upon av. All right, okay. So this was engineer Karthikeyan with his query. Let me see if there's any other query in the Google form. Mr. Karthikeyan is asking another query. Is there any guideline to design? Is there any query? Sorry, is there any guideline to design the earthquake resistance of steel structures using truss? Because recent code 18168 is only for moment resisting frames. No, no. So see, truss you are putting anyway on the top. Truss system you are putting on the top, right? It's a roofing system usually. It's a roofing system usually that you are using in truss. So you have your moment frames at the lower levels. Okay. So let's say this magenta thing is all your moment frames. for which sufficient guidelines have been provided in the code. And this is a independent truss system that you are putting on top of your frame. So this truss system need not be part of your lateral load resisting system anyway, because there is no not much self weight on the truss or not much imposed load on the truss. So in any way, it is not going to provide a lot of lateral load resistance also. So your magenta color is your moment frame SMRFs or whatever SCBFs or EBFs, whatever you are doing. And for this roof, you have a separate system of truss. So you can have trusses in higher seismic zones also. Got it? If you are asking that your movement frame itself has to be made of trusses, that means, let's say, if you want to make a system in which your instead of beams you want to provide movement frames or elements made out of truss like this, if that is your query, then there is no direct guideline given in the code right now about this kind of a system, that instead of beams I wanted some open web members like this as I'm showing you. Okay, and maybe something like this. So if you wanted an open web framing arrangement in your structure instead of beams, yeah, then for that you do not have any direct provision given. For that you do not have any direct provision given as of now. So maybe in that case you might have to come up with some jugaad work and do some manual calculations. You need to check that, let's say, instead of this beam, if I'm providing an open web section, try to check all the provisions of beam sections in this open web system also. But yeah, you're right, there are not much provisions given, because in beam they ask you for an doubly symmetric I section. In your open web you will, maybe you provide some built up channel with something like this lacing missing. So yeah, you are right, as of now it's not included in the 18168. In the American code, there are truss systems in AISC 341. Let me just confirm, although I have not read them. We have done a course on steel design based on AISC code. In that, we have detailed out AISC 341 also, but we stuck to SMRFs, SCBFs, and EBFs. But let me just see if the American code AISC 341 has any trust system. I think there is trust system also as a part of lateral load resisting systems. It does have, yeah, you have special truss moment frames. You have it. So I just put a screenshot. So I have never read it, but if you are interested, maybe you can. You see, I have put a screenshot over here. Special truss moment frames. Interesting. This is from AIC 341. Screenshot from AIC 341. Inelastic deformation capacity within a special segment of the truss. So this is your truss, and part of it I think will be dedicated to lateral load resistance. Interesting. Yeah, you read it. Maybe it might help you also. Okay. So this was engineer Karthikeyan with his query. Now we don't have any other query on the Google form. So let me just take up the queries from the live audience. Uh, Mr. Shubham J914 is asking, is there any batch from the start if someone wants to shift to structures and has no idea about how to start? So you may have a look at our basic courses on our website. So I think they are a great place to start. For RCC design, we have a separate course, and for steel design, we have a separate basic course. This is for Indian code also, and now we have basic courses on American codes as well, uh, which is I think no one else is offering something like this. So we are doing a RCC design course based on the ACI American code, ACI 318, and we have already done a steel design course based on the basic steel design course based on the AISC 360 code. So if you want to learn from the basics, you might be interested in having a look at these basic courses that we have done. Mr. Santosh Kumar Chandoli is asking, in dynamic analysis, spec X and spec Y load cases are generally defined considering positive eccentricity. Is it also necessary to no? So if you are doing it in ETABS, at least for dynamic cases, you need not define negative or positive values of eccentricity. You just give the eccentricity value, and then ETABS will consider all the possible eccentricities, that is plus minus internally. So uh, yeah, I mean, no need to separately define any positive or negative eccentricity value. Mr. Harish Acharya is asking how to model odd-shaped shear walls in ETABS. No, so it's very easy. In ETABS, you have the option of modeling line to area. So whatever odd shape, maybe if your wall is like this in plan view, okay, I don't know, but maybe if it's like this, in ETABS in plan view, you make a line arrangement like this in plan. So have nodes, have your line arrangements made like this, okay. Maybe just divide the nodes, provide more elements, maybe have a mesh size of around 1 meter or 0.5 meter. So now these are all your line elements. Now select all these line elements and use extrude. So in edit option, you will get extrude option, extrude line to area command. Use that and extrude it in along the elevation. So let's say along Z you extrude it, and then you can get any odd shaped wall modeled. So it's a 2-minute task. Okay, this option of extrusion was always there in the SAP 2000. It was not there in ETABS, but I think since last 6-7 years, I think after ETABS 18 or yeah, I think after ETABS 18 they have this extrusion option in ETABS also. So liquid retaining structures or any random shaped structure you can easily create using this uh, extrusion option. Okay. Mr. Vineet is talking about the basic courses. Very good courses covering every aspect. Thank you, Mr. Vineet. He has been a regular participant in all the AuxEn courses. So thanks a lot. Just give me a minute. Then Mr. Magaj is asking how to get the forces from portal frame system at beam column junction to design insert plate as column is RCC and beam is in steel. So you go to member forces, check the member forces at the beam ends. That's it. Simple. So you have a column in elevation, let's say, and this is your beam. And now you want an insert plate over here. So insert plate is getting connected to the beam, right? So you check the end forces, moments, whatever for the beams. Then Mr. Harish Acharya is asking when we shall expect new course on 1893. Yeah, so I think it is going to be enforced from May 2026, as I understand. So we'll try to do something before that. Right now, I have not read the code, not even, I mean, I have not read the code till now, so I don't know much about it. So maybe once I read it, we can plan something. Mr. Vinith is saying in my retaining wall case, the client is not willing to dig 2.5 meters, where the SPC is 10 tons per square meter. The conventional cantilever toe heel retaining was getting very huge. Hence, I went to think of pile system. No, no, your pile system is very good. I'm not saying it's not a good system. I'm just saying that let's say your client is not wanting to dig up to or 2.5 meters where you are getting a 10 ton per square meter SBC, but still you are anyway going to have 6 meter fill, right? So why not take the advantage of that 6 meter fill? So if this is your NGL and let's say your client is allowing you to only dig 1 meter or not even that, at least you are always going to get 6 meter fill. So if you introduce toe and heel slabs, you are able to get the advantage of the resisting moment that the soil fill 6 meter soil fill will offer. If you don't give that toe heel, you are missing out on that. So that's why I was thinking that have this pile system as it is, just maintain the toe heel also, and see your toe heel slab will also act as a pile cap. So your toe heel is also going to act as a pile cap. So maybe in locations where you have piles, you may provide a thicker something. You may provide a thicker pile cap, and in between this, the toe heel slab is slightly of smaller depth. You can think about that also. Okay. Mr. Vinith is saying, please have one sketch. Please one sketch. Please sketch the system that I should incorporate after eliminating the unnecessary ones. So, in my opinion, you try to eliminate. So, a simple, if you try it out, maybe if this is my plan view of the wall, okay, uh, you have your pile position wherever, let's say pile, these are my pile positions, okay, and have your pile caps like this maybe, and then this is my column. So have your toe and heel slab. Now in this will be a smaller slab, and this becomes my pile cap maybe, okay. Now have your columns maybe in between, placed in between, maybe like this. Then have a tie arrangement starting. Try to make it stiffer. Try to have this arrangement stiffer. Stiffer means it should behave something like a counterfort, something like this. Now, if I were to show you a front view, it will look like this, that this is my wall. Then, uh, okay, so let me show a sectional view from here. So sectional view from here will look like this. that there is a pile cap that I have provided, and then there are pile. Okay, so this is, oh sorry, this is my framing, right? Wait a minute. So this is my framing. This is my thinner toe heel slab that I'm providing. From this, I just take this column, maybe tie it like this. You check whether that frame has to be provided right till the top, this tie element, or maybe somewhere at mid height. You can introduce one more column over here if required. So this forms a stiffer system like this. Okay, the height of this you try and iterate and try and see which height looks okay. So this is my section, let's call it section 1 1, and for section 2 2 you have, let's cut it through pile cap. So I will have a deeper pile cap because it has to resist all the pile reactions. This is my pile, this is my pile, and at this section this is as it is. I Okay, so this is my section 2 2, and this is 2 2, this is 1 1. So try having something like this. Okay, there are researches, I mean people do it like this also, and there are many research work that goes that, let's say you had a toe heel slab like this. What if I were to introduce a slab in between slab like this? So what it does is that instead of having a uplift pressure acting like this on the total wall, because of introducing this additional cantilever slab somewhere at mid height, what it helps you to do is to break that soil pressure triangle into, let's say, two smaller triangles. So there will be some surcharge from the top plus a smaller earth pressure. So if you are able to provide stiff enough intermediate heel, or whatever it is called as toe heel, so if you are able to provide an intermediate slab like this, well connected to the cantilever retaining wall, this behaves better than a single cantilever wall where the triangular pressure is much larger and the overturning moments are much larger. So because of this intermediate element that you have introduced, you are able to break it down into two smaller sort of uplifts. Yeah. So when it is saying a beam should be given where the start slant beam is connecting the wall, you can provide that if required, but have its orientation like this. Okay, have its orientation like this. Okay, so this was Mr. Vineet with his query. Then we have Engineer Charles. In ETABS on shear reinforcement check, we have two values on either side of columns. So those two values indicate that in columns what happens. Let's say I'm showing you the plan view of the column. Okay. Now uh, let's say this is 3 3 axis, this is 2 2 axis. One axis is perpendicular to the screen. So there will be a shear force in this direction also, and there will be a shear force in this direction also. So you will need shear reinforcement for both these shear forces. So for V33, the bars that you are providing along the 3 3 direction are going to be effective. So for 3 3, these bars are going to be effective. Okay, bars in this direction. And for 2 2, these bars are going to be effective. You understand? So ETABS in its shear reinforcement check will show you two values. So one will be the shear reinforcement required for V22 shear. The other shear reinforcement requirement will be for the 3 3 shear. Right. Then Niju P. Reddy is asking in ETABS we are required to input windward and leeward coefficients for wind loads as per IS 875. Are these coefficients the same as the external coefficient CPE? See, same means you have to input yourself. ETABS is not smart enough to calculate those pressures. So whatever coefficient you calculate and apply, accordingly ETABS will calculate the member forces. So let's say if you're applying a coefficient over here, if you're applying using the coefficient system, then be careful that it has to include CP, CPI both. ETABS is not going to do the calculation for you. Understood? So personally, I don't sort of encourage applying these coefficients as such. It is always better that you calculate the wind forces yourself and then apply it as UDL or nodal points or whatever by yourself on the ETABS model. If you are applying the coefficients, please remember that ETABS is not smart enough to calculate these coefficient on its own. It's just allowing you to input those values. So whatever coefficient you are inputting, it has to be the combination of CP, CPI, whatever is applicable. You have to put it there. Mr. Karthikeyan is asking, please share some reference for EQ force on underground pits, like some process pits for equipments. Okay, so as of now, I don't have any ready reference for it. Uh, if I get it, I'll share it with you. Casa Grande is asking, is there off on course on the eve of New Year? Off means off on, oh, offer? No, so we don't have any offers throughout the years. There's no offer. The course prices are there on the website. Those remain the same for every participant. Yes. Right now we are doing a interesting course on the concrete design as per the American ACI code 31825. So it's going quite well. We are going to great depths while discussing that course, concrete design course on ACI 318. Mr. Magaj is asking which is correct surcharge value fire tender is taken as Ka times fire tender or 0.6 times Ka times fire tender load. So generally we try to multiply the pressure acting by Ka. That is what I generally take. What is there in the textbooks also. So whatever is the surcharge pressure over here, we usually take it Ka times that surcharge pressure. So I don't know from where 0.6 you are saying. Generally we take it as Ka. So whatever was the surcharge pressure, we take it Ka into surcharge pressure and apply it as a rectangularly distributed load. Anything else? Okay. So I think then that's it for this session. Uh, so you can continue to put your queries throughout the week. As you all know by now, I hope that the Google form remains the same. And every time when we meet once during the weekend, we will take the queries from that Google form. So just hold on. So I'm just putting the Google form over here. This is the 51st such episode that we are conducting. Yeah, so this is the link for the Google form. And if you want to message us on WhatsApp, then this is the link for messaging us directly on WhatsApp. So you can click and connect with us. So I think that's it for this episode. Then we will see you next weekend. Till then, have a good time. Thank you so much for joining. Have a good weekend. Bye bye.